As you can see, there are 4 SN74, HC74, and D flip-flop ICs. There's about 8 680 ohm fixed resistors. There's one 1K ohm fixed resistor. There's an E555P timer chip, as well as a 470 microfarad capacitor. There's also a 103 ceramic capacitor with there's also 3 momentary push buttons, as well as 4 10K ohm fixed resistors. Finally, there's 9 LEDs, with 4 of them being green, 2 of them being yellow, and 3 of them being... So when powered, the LED circuits are ready to receive the data, but obviously they're not lit up. When the data button is pressed and a high is sent to the first flip-flop using the clock as a result of the clock button, on the rising edge of the clock signal, each flip-flop receives a signal in the input and sends it to the next to the output and sends it to the next input, as you can see, especially with these brown wires. The LEDs are what allow us to see the 8-bit number stored in the register, and this is the clear or reset button that is wired to every clear or reset pin of the flip-flops. And when that button is pressed, it sends a low to the clear pins, resetting all the outputs to low and turning off the LEDs. And we can see that here. Oh. When we press clear, all of them turn off. So, the 555 IC is a monostable mode and generates a clock signal when the clock button is pressed. This helps avoid any errors or glitches. It's also why all the clock pins of the chips, where there are 2 per each SN74, HC74, and IC, are connected to the pin 3 of the 555 timer, which is the output. Pin 1 and pin 8 are dedicated to power and ground, while pin 2 is where a button is usually connected to act as a trigger. Pin 3, as I mentioned, is the outputting of the clock pulses, while pin 4 is set to high to disable the reset function, which helps prevent any unintentional resets. When connected in serial configuration, each output, which is Q, for example, there's 1Q and 2Q, where the LEDs will be on. When four of these ICs are lined up and connected, the 1D would be connected to the input and the output would be 1Q. On each of these outputs, there's also an LED, as I mentioned. The purpose of this project is to build an 8-bit shift register using the 4 ICs and to mimic the core function of the 74HC595 shift register. I hope you learned something, and I hope you understood the applications of shift registers and their role in data storage.